finding out about data sets helps to know more about where the center of the data set is, what the spread of the data set is, and other types of descriptive statistics. So as an example, here we have an example of BMI, which is your body mass index, and based off of your explanatory variable would be the income that a person might have. So if you make less than the median, this is your data set. If you make greater than the median, this is your data set. If we want to see a little bit bigger data set, let's actually make the data set about 500 data values. And then you can see a little bit more what's going on, see a little bit more data. We can also get much smaller so you can actually see the actual data. So we could do like, let's say 10 or 20, there the 20. So now I can see those actual data points and see what's going on. And I can see what happens with it. I can calculate their means and so forth, or their centers, I should say. So let's go back to 500. And I'd like to know, where is the center of this data set? So where does it look like most of the data is, or where the center might be? And it looks like it might be somewhere about 35 for if your income is less than the median, about the same thing if it's more than the median. So the question is, which one is it and what is happening with it and what the values are? So we can actually find that center. There's two different ways to measure a center. One way is what's called a mean, and one way is what's called a median. So I'm going to go ahead and turn on the mean. And I'll make the graph a little bit bigger so you can see it a little bit better. So here's your dots. Here's your mean for if your income is less than the median income, and here's your mean BMI if it's more than. So it almost looks like they're exactly the same. So it's not like income makes any difference. Mean is one way. We can also do the median. And I'm going to turn off the mean at the moment. And here's the medians. And the medians, again, look exactly the same. And what the mean is where you add up all the data values divided by how many there are. Whereas the median is actually the middle value. So there's half the data points. So this sample size was 500. So half of the data points are above it. So 250 data points above, 250 data points below. Same here. Let's make it a little bit smaller so you can actually see them a little better. Sorry, go with that. So here again, you've got half your data points above, half below. Now there actually isn't, there's 250, there's 20 amongst both of these, so there won't exactly be, but notice there's 3 data points above and 3 data points below. This one again, same idea, you have the same number above as below for your median. The mean is a little different. I'm going to show both at the same time. In this case, notice the mean is a little different from the median. The mean is being pulled up by this value that's a bit higher. Whereas here they're almost exactly the same because most of the data points are just about the same on this one. Again, I'm going to make my sample just a bit bigger here. And we can see a little bit more about what's going on and see those values. So here now, because I took a new sample, there's not a lot of difference between above and below. So mean and median are about the same here and almost the same here. And so that center gives you that idea. We can take another sample and we can see how the difference is. And so now we can see the median is below the mean here. And again, that's because there's some values that are a bit higher here that pulls the mean up, whereas the median is not usually affected by those outliers. Here, they're almost exactly the same because there really aren't that many outliers here. Take another sample. Now you can really see not much difference at all. Even though there's a point up here, there's some points down here that balance it out. And you can keep doing this and take different samples and see what the difference would be. Notice in this case, the mean is always going to be, if it's not the same as the median, it's going to be a little bit above it, just because there's higher values and not a lot of lower values that will pull it up. So the center is very important, but another part that's also important is what we call the standard deviation. And this is what we call the standard deviation ruler. It actually is showing you what the standard deviation is, and the standard deviation is a measure of your variability, how much spread is in your data. So how spread out is the values, how different are they, basically think of it that way. And so here you notice most of the values are within one standard deviation. Almost all of them are within 2 standard deviations. What that means is you're taking your mean, adding your standard deviation once, then adding it twice. You can also subtract once and subtract twice, and that's what the different values mean. On this graph here of less than the median, you've got BMIs that are above the standard deviation, 2 standard deviations away from the mean. That's where we start talking about them being unusual. And we don't have any values below. If I change to a different variable, we can actually go to something different. We can look at maybe pulse rate and see what the pulse rate looks like. Again, I'll look at the bigger graphs. Here now, again, you can see in this case, we have a lot of values that are above 2 standard deviations. So these are considered kind of our extreme or rare values. 3 standard deviations are really rare. These look like they're probably the 3 standard deviations above. We also have a few values that are uncommon that are below in pulse rate. So some people have really low pulse rates. Same here. If your income is above the mean, this is what your pulse rate would be. And if you're really, you've got some unusual values here. So this is what the standard deviation does, is it tells you kind of how spread out the values are. The smaller the standard deviation is, the less less spread out the data is. The larger the standard deviation, the more spread out they are. Because this 1 and 2 standard deviations would be a lot longer for bigger standard deviation. We can actually compare and create another model if we want to. So I can actually get another model here, another sample, freeze it, and then take another sample, and you can see the difference of how they look. Take another sample if you want. You can compare to this one, and you can see that the standard deviation pretty much stays the same for these, and the means and medians kind of stay the same. A little different for different samples, but that's basically what's happening. All right. Then if we go back, we can pick a different variable if we want and just look at this. But this is what our standard deviation does, is it tells us how spread out they are, and then the mean and medians tell us kind of where the center is. There's a code book here that tells you what the different variables are. So if you want a different variable you want to look at, you can look at that. We don't want that one. So that gives you some idea of what's going on. This tells you a little bit more about the little app of what different things do. There's also stats. We can look at the actual values. We can actually calculate what those values are. We can see that for the current one, our standard deviation at the mean, our standard deviation, what that is, and what your mean is. Actually, it doesn't have the mean on here. It just says your standard deviation, because standard deviation is so important. We can turn off standard deviation, and then you won't get anything here. Well, it looks like it's always going to give you that, but it gives you an idea of what their difference are. So the current one, it was 12.1. This new one is 12.4. So again, they're not very different for each other. This breaks it down based on your different income levels. So this is below the mean and above the mean, and what those would be. So this gives you an idea. Standard deviation tells you spread. Mean and median tells you just about the values of these and what they're looking like, and how spread out they are. Okay, and again, if you've got some values that are really far up, your mean will be different from your median, whereas if they're much closer or you've got values from above and below, your mean and median will be similar to each other. And this is what descriptive statistics do for us, is they give us an idea of what's happening.